everyone. So today we are going to start our exercise 2.2 of our second chapter Polynomials of class 10. And before we move on to our exercise, let's discuss some important points which are really useful for this exercise. And that is, if alpha and beta are the zeros of a quadratic polynomial, ax square plus bx plus c equal to 0, where a is not equal to 0, then the sum of the zeros alpha plus beta is equal to minus b by a, and the product of the zeros alpha beta is equal to c by a. Now what is this a, b and c? A is the coefficient of x square, b is the coefficient of x, and c is the constant term in the given quadratic polynomial. Now what is the second point? The quadratic polynomial with the zeros alpha and beta is given by k into x square minus sx plus p, where s is equal to alpha plus beta and p is equal to alpha beta, and k is not equal to 0 and k is always real. So if you are given with this sum and product of the zeros, then it is easy to find a quadratic polynomial. You just need to substitute in this formula k into x square minus sx plus p, regarding k is not equal to 0. So now let's move on to our exercise 2.2, question number 1. And this is our first question, which is find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. And part 1 they have given as x square minus 2x minus 8. So to find out the zeros, what do we do first? We equate the given quadratic polynomial to 0. So here p of x is equal to x square minus 2x minus 8 is equal to 0. Now when we split the middle term, what do we get? We get it as x square minus 4x plus 2x minus 8 is equal to 0. From the first two terms, I take x common. So I get x into x minus 4 plus from here I take 2 common. So I get 2 into x minus 4 is equal to 0. Now here what do I get? I can write it as x plus 2 into x minus 4 is equal to 0, which implies either x plus 2 is equal to 0 or x minus 4 is equal to 0, which implies x is equal to minus 2 comma 4. So now you have got the zeros of the given polynomial. Now what do you have to do? They have asked you to find out the relationship between the zeros and coefficients. So let's find out the relationship. For that, first I am finding the sum. Now what is the sum of the zeros? Minus 2 plus 4. Minus 2 plus 4, and our answer is 2. And this 2 I can write it as minus of minus 2 by 1. This is equal to minus of minus 2 by 1, which is the same as minus of coefficient of x by coefficient of x square. So this is one of the relation. Sum of the zeros is equal to minus of coefficient of x by coefficient of x square. Now let us find out the product of the zeros. Product is minus 2 into 4, which is equal to minus 8. This I can write it as minus 8 by 1. This is same as minus 8 by 1, which is equal to the constant term by the coefficient of x square. So this is our second relation between the zeros and the coefficients. So now let's move on to our next question, part 2. So this is our part 2, which is 4s square minus 4s plus 1. So what do we do first? We equate the given polynomial to 0 to find out the zeros. So here it is p of s is equal to 4s square minus 4s plus 1 equal to 0. Now we are going to split the middle term. So you get 4s square minus 2s plus 1 equals 0. Now from the first two you take 2s common. So you get 2s into 2s minus 1. From here you take minus 1 common. So you get 2s minus 1 equals 0. So this implies either 2s minus 1 equal to 0 or again 2s minus 1 is equal to 0. So this implies s is equal to 1 by 2 comma 1 by 2. So these are our zeros. Now let us find the relationship between the zeros and coefficients. So for that we first find our sum, which is 1 by 2 plus 1 by 2. What do you get that? You get it as 2 by 2, which is equal to 1. That I can write it as minus of minus 4 by 4, which is equal to minus of coefficient of x by coefficient of x square. So now next, what do you find? You find the product. So what is our product? Product is equal to 1 by 2 into 1 by 2, which is equal to 1 by 4, which is the same as the constant term of the given polynomial by the coefficient of x square. So this is part 3, which is 6x square minus 3 minus 7x. So what is the first step? We equate the given polynomial to 0. So we can write this as p of x is equal to 6x square minus 7x minus 3 is equal to 0. I even rearranged the polynomials. So now how can we split the middle term? This can be written as 6x square minus 9x plus 2x minus 3 is equal to 0. Now what can you take common from here? I can take 3x. So you get 2x minus 3 plus from here 1. I take common. I get 2x minus 3 equal 0. This can be written as 3x plus 1 into 2x minus 3 equals 0, which implies either 3x plus 1 equal to 0 or 2x minus 3 equal 0, which implies x is equal to minus 1 by 3 comma 3 by 2. So now let's find out the sum. We have already got our zeros. So what is our sum here? Sum is equal to minus 1 by 3 plus 3 by 2. After finding the LCM, you get minus 2 plus 9 by 6, which is equal to 7 by 6, which can be written as minus of minus 7 by 6, which is equal to minus of coefficient of x by coefficient of x square. Now let us find out the product. What is our product here? Product is equal to minus 1 by 3 into 3 by 2. You get thus minus 1 by 2. Now how will you write this minus 1 by 2 as? I can write it as minus 3 by 6. So this is equal to minus 3 by 6, which is equal to the constant term of the given polynomial by the coefficient of x square. So this is our relation. Let's move on to our next question, which is part 4. So this is our part 4, which is 4u square plus 8u. So to find out the 0, first what we do? We equate the given polynomial to 0. So this is p of u is equal to 4u square plus 8u is equal to 0. From here you can take 4u common. So what do you get? 4u into u plus 2 is equal to 0, which implies either 4u equal to 0 or u plus 2 equals 0, which implies u is equal to 0 comma minus 2. So now you have got our two zeros. Now let's find out our sum. What is our sum here? Sum is equal to 0 minus 2, which is equal to minus 2, which can be written as minus of 8 by 4, which is equal to minus of coefficient of u by coefficient of u square. So now let's find out the product. That is, product is equal to 0 into minus 2. 0 into minus 2, which is equal to 0, which is equal to, what is a constant term here? It is 0. So it can be written as 0 by 4, which is equal to constant term by coefficient of u square. So this is our relation. Let's move on to our next part, which is part 5. Now this is our part 5, which is t square minus 15. So first what do? We equate our given polynomial to 0 to find out the roots. So here we get t square minus 15 equals 0. Now how can I write this t square minus 15 as? I can write it as t square minus root 15 the whole square equals 0. Now this is of the form a square minus b square. What is the identity? A square minus b square is equal to a plus b into a minus b. So this implies t plus root 15 into t minus root 15 equals 0, which implies either t plus root 15 equals 0 or t minus root 15 equals 0. This implies t is equal to minus of root 15 comma plus root 15. So now we have got our zeros. Next we need to find out the relationship between the coefficients and the zeros. So sum is equal to minus root 15 plus root 15, which is equal to 0. This can be written as minus of 0 by 1. This is equal to minus of coefficient of t by coefficient of t square. Now next we need to find out the product. So what is our product here? Product is equal to minus of root 15 into root 15, which is equal to minus 15. So how can you write it as? You can write it as minus 15 by 1, which is equal to constant term by coefficient of t square. So this is a relation between the zeros and the coefficients. So let's move on to our next part, which is part 6. This is our part 6, which is 3x square minus x minus 4. So first what we do? We equate a given polynomial to 0. So we get p of x is equal to 3x square minus x minus 4 equals 0. Now we split the middle term. So you get 3x square plus 3x minus 4x minus 4 equals 0. Now taking 3x common here, you get 3x into x plus 1 minus 4 common, you get x plus 1 inside here. So this implies 3x minus 4 into x plus 1 equals 0, which implies either 3x minus 4 equals 0 or x plus 1 equals 0. That is, x is equal to 4 by 3 comma minus 1. So here you've got the zeros. Now let us find the relationship between the zeros and coefficients. For that you find the sum first. Sum is equal to 4 by 3 minus 1. So 4 by 3 minus 1, which is equal to 4 minus 3 by 3, which is equal to 1 by 3. This can be written as minus of minus 1 by 3. Now it can be written as minus coefficient of x by coefficient of x square. Next we are going to find the product. What is our product? Product is 4 by 3 into minus 1. 4 by 3 into minus 1, which is equal to minus 4 by 3. Now this can be written as constant term by coefficient of x square. So this is our relation. So now let's move on to our next question, which is question number 2. So this is our second question, which is find a quadratic polynomial each with the given numbers as the sum and product of its zeros. So part 1, they have given 1 by 4 as its sum and minus 1 as the product. So how can you write a quadratic polynomial when you are given with the sum and the product? Can be written as k into x square minus sx plus p, provided k is not equal to 0 and k is real. Now this is one of the important points which we discussed before starting our exercise. So now I'm going to substitute the value of s and p here. So I get it as k into x square minus 1 by 4x minus 1. Now I'm going to find the LCM. So I get as k into 4x square minus x minus 4 by 4. Now when k is equal to 4, what happens? 4 into 4x square minus x minus 4 by 4. 4 and 4 get cancelled. So I get the quadratic polynomial as 4x square minus x minus 4. So this is how you find a quadratic polynomial when you are given with sum and product. So now let's move on to our next question, which is part 2. So this is a part 2, which is root 2 and 1 by 3. So sum is given as root 2 and product is given as 1 by 3. Then how can you write a quadratic polynomial? It is written as k into x square minus sx plus p, where k is not equal to 0 and k is real. Now we are going to substitute the value of s and p here. So you get it as k into x square minus root 2x plus 1 by 3. Now I am going to take the LCM. So you get k into 3x square minus 3 root 2x plus 1 by 3. Now what is our next step? When k is equal to 3, what do you get? You get 3 into 3x square minus 3 root 2x plus 1 by 3. 3 and 3 gets cancelled. So what do I get the polynomial as? 3x square minus 3 root 2x plus 1. So this is our required quadratic polynomial when the sum is root 2 and product is 1 by 3. Now let's move on to our next question. Now this is our third question, which is 0 and root 5. So here sum is given as 0 and product is given as root 5. Then how will you write a quadratic polynomial? It is written as k into x square minus sx plus p, where k is not equal to 0 and k is real. So now substituting the value of s and p, you get x square minus 0x plus root 5. So this can be written as k into x square plus root 5. Now what value will you substitute for k? When k is equal to 1, what do you get? X square plus root 5. So this is our required quadratic polynomial when the sum is 0 and product is root 5. So now let's move on to our next question, which is part 4. So this is our part 4, which is 1 and 1. So given sum is equal to 1 and product is equal to 1. Now how do you represent the quadratic polynomial? Just k into x square minus sx plus p, where k is not equal to 0 and k is real. So now let's substitute the value of s and p. You get k into x square minus x plus 1. So now when k is equal to 1, what do you get? You get the quadratic polynomial as x square minus x plus 1. So this is our required answer. Now let's move on to our next question, which is part 5. Now this is our part 5, which is minus 1 by 4 and 1 by 4. So here sum is given as minus 1 by 4 and product is given as 1 by 4. Then how can you represent the quadratic polynomial? It is written as k into x square minus sx plus p, where k is not equal to 0 and k is real. Now let's substitute the value of s and p. You get k into x square plus x by 4 plus 1 by 4. Now I'm going to take the LCM. So I get k into 4x square plus x plus 1 by 4. Now what will you put the value for k as? When k is equal to 4, what do you get? 4 into 4x square plus x plus 1 by 4. So I can cancel 4 and 4. I get the polynomial as 4x square plus x plus 1. So this is our required answer. So now let's move on to our next question, which is part 6. So this is our part 6, which is 4 and 1. So given sum as 4 and product as 1, then how can you represent our quadratic polynomial? It is written as k into x square minus sx plus p, where k is not equal to 0 and k is real. So now substituting the value of s and p, you get k into x square minus 4x plus 1. So now what value will you substitute for k? When k is equal to 1, you get x square minus 4x plus 1. And this is our required quadratic polynomial. And that's all for today. We finished with our exercise 2.2. In the next class, we'll move on to our exercise 2.3. So till then,